This is part 2 of 1.14. So we're going to start in with density. The density of water is 1.0 grams per milliliter or 1.0 grams per cubic centimeter. Remember, 1 milliliter and 1 cubic centimeter of water are the same amount. If you have a mass of 750 grams and a volume of 1,000 cubic centimeters, what is your density? If you feel you can do this, hit the pause button, figure out your answer, and you can check it with mine. First step, always list everything that you know. I know my mass is 7,500 grams, my volume is 1,000 cubic centimeters, and I'm solving for density. So my formula is density equals mass over volume. I plug in my numbers, and the answer is 7.5 because I took 7,500 grams divided by 1,000 cubic centimeters. But what is the unit? You divided grams by centimeters, and neither cancel. So your complete answer is 7.5 grams per cubic centimeter. All right, so let's do another one. If Kaylee's mass is 60 kilograms and her density is 2.5 grams per centimeter cubed, what is her volume? Will she sink or float? Okay, let's answer this question first. Her density is 2.5 grams per cubic centimeter. Is she going to float or sink? Well, we need to compare that with the fact that water's density is 1.0, and therefore, since her density is more, she is going to sink. Yep. All right, so she's going to sink. We can just put that in there, and then let's calculate her volume. Again, if you feel like you have a handle on this, please hit the pause button, do it yourself, and check your answer with mine. The reason for that is it is so easy to listen to a teacher and go through and go, yep, okay, yeah, I got this, no problem. And then you get to the quiz and you get it wrong. Why? Because your brain works differently if you write it, if you hear it, if you see it. So if you think you can, solve this on your own first and then listen to me talk it through, check your answer. And if you're not there yet, that's okay. That's why I'm doing practice ones. So list what you know. So I know my mass is 60,000 grams. Did you catch that I am not using 60 kilograms because my density is in grams? Okay, here's where the units are crazy important. If I'm saying my density is in grams, I can't use kilograms for my mass. So I have to convert 60 kilograms into grams. So we know that 1 kilogram equals 1,000 grams. Therefore, if I have 60 kilograms, it is going to equal 60,000 grams. The density is 2.5 grams per centimeters cubed, and volume is abbreviated V. All right, what formula are you going to use? Well, we're going to use density equals mass over volume, but you need to use your algebra skills to solve for V. So V equals mass over density. Put in your numbers. So 60,000 grams divided by 2.5 grams per centimeters cubed. That's the same as these two fractions. 60,000 grams over 1 times 1 cubic centimeter over 2.5 grams. Okay? And it has to do with the math rules of fractions over fractions. You flip them. Another way to think about it is, since the 2.5 is on the bottom of my first fraction, it's got to be on the bottom of a fraction, and it's grams per centimeter cubed. So this is how you would set it up. If you're like, whoa, I just totally got lost on this, but I can do it if I do it this way, that's fine. Okay? We're going to be talking more about this style later on this year, but I just wanted to throw it out there. So if it does make sense to you, great. Keep that in mind, that explains the why of how the units cancel. If you look at it and go, I don't know, but I know the grams cancel and I know my answer is centimeters cubed, that is good enough for now. All right. Answer is 24,000 cubic centimeters is her volume. All right, so let's do another one. If Mariah's volume is 0.92 grams per centimeter cubed and her density is 0.92 grams per centimeters cubed, what is her mass? And let's fix that problem. Sorry about that. Hopefully you caught that right away. The volume is 76,000 centimeters cubed. Her density is 0.92 grams per centimeters cubed. What is her mass? Will she sink or float? So what is she going to do? Sink or float? Well, what's the density of water? Water is 1. Is her density more or less? Less. Therefore, she will float. All right, let's calculate her mass. List what you know. Mass is m. Density is 0.92 grams per centimeters cubed. The volume is 76,000 grams per centimeters cubed. What formula are you going to use? Density equals mass over volume, but you need to use your algebra and rearrange it for the mass. Again, if you're doing this along with me, hit pause in between or hit pause and give me your whole answer. So we are going to, with our algebra, get the formula mass equals density times volume. Now put in your numbers. 76,000 centimeters cubed times 0.92 grams per cubic centimeter is going to equal our mass. And this is the same as putting them in fraction form. So again, instead of just writing 76 cubic centimeters, I can put it over 1. Instead of writing 92 grams per centimeter cube, I can actually put the centimeter cube on the bottom of my fraction. By doing so, you can really easily see how the 2 units of centimeters cubed cancel. When you write it as a fraction, it's easier to see how units cancel. The answer is 69.92 grams. Next question, which person has more mass, or really we can also consider it weight, on Earth? They're close enough. Kaylee or Mariah? So there is Mariah's, and Kaylee's was here. And you may have noticed my mistake. I hope you did. I didn't catch it until I put it up here. So as you have realized, I'm the one making up all these notes, and I'm sure you know sometimes when you write stuff up yourself, it's easy to make little mistakes. So when you put this in your calculator, the answer you should have got is 69,920. So 69,920 grams, which equals 69.92 kilograms. So I had just immediately converted it to kilograms because that's usually the unit we use for measuring people or large objects. Objects that weigh more than 2 pounds, we usually use kilograms for. Because 1 pound, just in case you were wondering, equals 2.2 pounds equals 1 kilogram. So every kilogram is about 2 pounds. All right, so let's go back to this question where it said which one weighs more, Kaylee or Mariah? All right, so Mariah weighs more, and that's because she has more mass. Okay, now Mariah floated, right? But she floated. Do you understand why? Even though she has more mass, she floated and Kaylee sank when they went swimming. Do you understand why? And the why is Mariah had a greater volume. So if you picture them swimming, Mariah was laying flat and floating in the pool, whereas Kaylee was tucked up into a ball. And therefore, Mariah has less density. So she was spread out, and therefore she has less density. Because even though she did weigh more, we're only talking like 20 pounds different. And I don't want you to think, oh, well, maybe it's because, it's fat and fat floats. No. Okay? We'll just assume that Mariah's taller and maybe Kaylee's, in 5th grade and Mariah's her older sister who's in high school. Okay? All that stuff. What I want you to focus on with this question is whether you float or sink is not based on how much you weigh, but it's based on your density, which is a combination of how much you weigh or your mass and volume or the space that you're taking up. Okay, we're going to go on to the next part of the lesson, which is talking about large and small numbers can be represented by scientific notation. Chemists often work with very large and very small numbers. If you look at the reaction for extracting mercury from cinnabar, you will see the mercury sulfide combines with oxygen. Oxygen has a density of 0.00 133 grams per cubic centimeter, compared to mercury's density of 13.6 grams per centimeter cubed. How can you more easily express the small number for oxygen's density? You do this with scientific notation. Scientific notation is a form of shorthand. Any number can be expressed as the product of two numbers. So the first part that you have is a coefficient. The coefficient is, in this case, this number right here, and it's always going to be a number between 1 and 10. Then the second part is 10 raised to some exponent, that is, to the power of 10. So 10 to the negative third power. For example, oxygen's density of 0.0013 grams per centimeter cubed can be expressed as 1.33 times 10 to the negative third grams per centimeter cubed. Scientific notation allows chemists to represent numbers that have many figures in a shorter format. Scientific notation is a method of expressing a number as the product of a number greater than or equal to 1 and less than 10, and a power of 10. So in other words, you have to have this format. Let's review some powers of 10. 10 to the first power simply means 10. 10 to the second power is really the same as 10 times 10, which is 100. 10 to the third power is 10 times 10 times 10, which is 1,000. 10 to the fourth power is 10,000. So you can see there's a huge difference. Think about money. There's a huge difference between 10 to the first power and 10 to the fourth power. Okay, it's not that you have $3 more, it's that you have 9,990 more dollars. So huge difference. So what about if we go the opposite way? What about if we have negative exponents? Well, negative in math class means the opposite of. So instead of multiplying, we're dividing. So 10 to the negative first power is the same as 1 over 10, which is 0.1. 10 to the second power is 1 over 100, which is 1/100th, or 0.01. 10 to the negative third is the same as saying 1 divided by the quantity 10 times 10 times 10, or 1 divided by 1,000, which gives you 1,000th, with that nice little th at the end, 1,000th. And then 10 to the fourth is 0.0001. So again, huge differences with powers of 10. And in our notes, I started a new section of scientific notation, and I just copy-pasted that and just put an example of it to kind of remind everyone about powers of 10. Scientists follow rules for scientific notation. Scientific notation tells you how many times the coefficient must be multiplied or divided by 10. In other words, we're just moving the decimal. That's what dividing or multiplying by 10 does. It moves the decimal. Let's look at some examples. 800 equals 8 times 10 times 10, or 8 times 10 squared. 0.08 equals 8 divided by the quantity 10 times 10, or 8 divided by 10 squared, or 8 times 10 to the negative 2. So it's all the same. Now if you're thinking, why on earth would you write it like this when you can write it like that? It's because in chemistry, we have numbers so small. When we talk about the atoms, it's 0.0 and 23 zeros before you get to a number. So it is literally 0.00000000000000000000006. Okay? All those zeros are in there before I got to the 6. And because of that, it takes up way too much space. It's too confusing. So the really big and really small numbers are the why behind scientific notion. Yeah, we hardly ever use them with numbers that are this normal for everyday use, but you can. All right, these are the rules of scientific notation. Numbers greater than 10. Exponent equals number of places the decimal place has moved to the left. All right, so we have our number right here, which is 625 million. You count how many places you move the decimal in order to just have one number in front of the decimal. So I'm going to pause there. I know it's a bad time to pause, but my video is going to run out and we will pick up right here in the next video.